In this video, we will learn the formula to find the area of a rhombus. I have a plain sheet of paper here, so first I'll cut out a rhombus out of it. There I get a rhombus. How do I know this is a rhombus? Well, the definition of a rhombus is that all its sides are equal. So if I see this side is equal to this side, which is equal to this side, that is equal to this side. So all sides are equal. They may not be at right angles to each other, as in a square, but they are equal. Also, we can notice clearly here that the opposite sides are parallel in a rhombus. So this side is parallel to that side, and this side is also parallel to that side. And also opposite sides are equal, obviously, because all sides are equal. So even opposite sides are equal. This means that a rhombus is also a parallelogram. So this is a special case of a parallelogram. So the definition of parallelogram was opposite one pair of opposite sides that are equal and parallel. So they are equal and parallel, or in other words we can say opposite sides are parallel. So these two opposite sides are parallel and these two opposite sides are parallel, and therefore this is also a parallelogram. So one way to find the area of a rhombus is to use the formula to find the area of parallelogram. So in that we could just take the base of the rhombus, multiply that by its corresponding height. The second way is we can divide the rhombus into two triangles. So how do we do that? Well, we can cut the rhombus into two triangles along this diagonal. So I'll just cut this rhombus into two. So there I go. I get two pieces. I have divided the rhombus into two triangles. So this was my rhombus. Then I divided it into two triangles. Now how to find the area of the two triangles? Well, I can place them like that, and all I need to do is find the area of this triangle and add that to the area of that triangle. So what is the area of a triangle? Well, we've learned that in the last video. The area of a triangle is its base times its height into half. So area, I'll just write that, area of triangle 1, let's say. Okay, let's call that triangle 1 equals half into, let us call this length A. Well, let that be A. Okay, so A, I can write that half times A, which is the base, times this height. So let me call, so I'll just draw this line there, this. So let me call that B. Okay, so half times the base, which is A, times the height, which is B. So I'll just write B there. That is the area of this triangle. What is the area of triangle 2? This triangle. So that is half times the base. So let me call this base, let me call that. So yeah, one thing that I need to remember is that this was a rhombus, right? So this side is equal to this side. So if that is A, this has to be A. So I'll label this side also as A. Okay, so now if I'm finding the area of this triangle, the base is A. Okay, that's A times this height. So what do I call this height? Well, let me just call it, I'll just label this height as, let me call this as C. Let's say I call this as C. So the area of this triangle is half times the base, which is A, times the height, which is C. That's the area of this triangle. Now what is the area of the whole rhombus? I can add the area of triangle 1 and the area of triangle 2. So I'll just put a plus sign there. Area of triangle 1 plus the area of triangle 2 will give me the area of the rhombus. Sorry for the bad handwriting, but area of the rhombus. So this plus this should give me the area of the rhombus. So if I add these two expressions, what do I get? I'll just write that here. Okay, half AB plus half AC, right? Now in this expression I can just rewrite this expression as, I can just take the half common and I can write that as half. I can also take the A as common, so let me just take the half first common. AB plus AC. So when I open the bracket, I get half AB plus half AC. Half AC. Okay, that's how simple. This multiplied with this gives me this. This times this gives me this. Now I can take the A common and I get A by 2 B plus C. A by 2 into B gives me this expression, and A by 2 into C gives me this expression, right? So if I now look at this rhombus, what is B plus C? Well, this is B, and this is C. What is B plus C? Well, this is the whole diagonal. This is diagonal, right? So I can say that B plus C is the diagonal. Let me call this as diagonal 1. So I can write this as diagonal, or D for short, D1. What is A? Well, A is the second diagonal here. So I can write that as this A is the second diagonal. So the second diagonal, or diagonal 2, and obviously I have the half there, sorry, multiplied. Half into D1, which is my A here, D1 first diagonal, times D2, which is the second diagonal, B plus C, second diagonal. So what I get is the area of a rhombus. So I was finding the area of a rhombus is half times first diagonal times the second diagonal. So that is how we find the area of a rhombus using two methods. We can use this formula, or we can use the formula for the area of a parallelogram. That's it.